All right, guys, today I have yet another fantastic guest on the show, Lee Smolin, a theoretical physicist. Before I say hello to him officially, let me tell you a bit about him. He's a founding and senior faculty member at the Perimeter Institute for Theoretical Physics, adjunct professor of physics at the University of Waterloo, member of the graduate faculty in philosophy at University of Toronto. I checked his Google Scholar citations. It's over 19,000, so I've got a bit before I catch up to him. Author of The Singular Universe and the Reality of Time, Time Reborn, from the Crisis in Physics to the Future of the Universe, The Trouble with Physics, Three Roads to Quantum Gravity, and The Life of the Cosmos. How are you doing, sir?
Very fine. Thank you very much.
I'm so excited
Thanks for having me on the show.
Thank you for accepting. Well, we were brought together through a gentleman who works at a very interesting nexus in terms of science and Hollywood. How do you promote some of these Hollywood productions that contain a scientific content? And that's how he thought that it might be fun for us to chat, precisely because you are one of the scientific advisors of the forthcoming documentary Voyage of Time, narrated by some unknown actor known as Brad Pitt. So I thought maybe you'd tell us first about the documentary and maybe how you got involved in the project.
Well, The Voyage of Time is not really a documentary.
Okay.
And let me start that by saying that Terrence Malick is not really a Hollywood filmmaker. He's an experimental filmmaker.
So I got basically everything wrong.
No, I'm just working with the material you give me. But he's an experimental filmmaker, and I think, to my mind, a great artist who happens to have had enough success and recognized success to be funded through the Hollywood system. But he's in Austin, Texas. The Voyage of Time is a project he's been working on for at least 30 years, I'm told. It's a poetic, visual recreation of the history of the universe from the Big Bang, which shows the formation of galaxies, the formation of stars, the formation of planets, the formation of life on the Earth, the growth and the evolution of life, all the way up to us human beings and beyond. It's not really its intention, as I understand it, and as I experienced it, I've seen several versions of the film, is to inspire, to evoke wonder, to evoke fascination. It's not so much to educate. It's not a pedagogical film such as comes from National Geographic or PBS or something like that.
Gotcha. You know, I received I haven't seen the, what did you call it instead of documentary? What was it, a poetic? What was the term you used?
I think of it as a visual poem.
Okay, fair enough. I haven't seen it yet, but I saw the trailer, which is available publicly, but I received the production notes, and as I was quickly perusing through them, there's one quote from, I guess, the chief scientific advisor. His name is Andrew Knoll. Let me just read the quote because I think it speaks to something that's quite important. So every scientist I know thinks the universe, life, and all of the phenomena of nature are mysterious in the best possible way. Knowledge doesn't lessen your sense of beauty and mystery, it enhances it. Our job as scientists is to reach into that mystery and try to build understanding, and that is also what Terry does in his own way with this movie. I mean, I thought that was great because I face some of this issue of, well, you know, if you explain something, you remove the awe-inspiring element. If you explain the evolutionary roots of romantic love, well, then you demystify it. So I thought that was a very poignant quote. Perhaps you could comment on that.
Well, let me respond with a quote of a friend of mine, the sculptor St. Clair Semen. That you mentioned my book, Life in the Cosmos. I was interviewed for that by a BBC documentary years ago. And I came back to New York and was taken to a party by St. Clair, who was a great artist. And I was complaining to St. Clair that I hadn't gotten my point across. And I was very frustrated in the interview. They didn't seem to get it. And he said, I don't understand what your problem is. The message of your book is very simple. And I said, okay, what is it? He said, the whole splendor of the universe is so magnificent that even the absence of God would be God enough.
Very nice. Which leads me to, I think we were talking about this offline. We're both Jewish, Shana Tova, formally to you and your loved ones. In a sense, perhaps if there is a granddaddy in the sky, maybe he's happy that instead of being in one house of God, which is the synagogue, sitting here and talking about the magic of the universe is a form of worship. Perhaps it's a form of non-religious worship, but nonetheless, it's a form of worship, no?
In the best way. And
Right.
Happy New Year to you.
Thank you, sir.
But I think to come back to the film, I think Terry Malick's film is a spiritual or religious experience. It comes out of that kind of yearning in the director and the other people involved in the project to portray the beauty and the wonder of the universe in a way that makes it accessible and inspirational to anybody who would go see it. I don't know how to emphasize this extraordinarily beautiful experience.
Well,
They,
I'm sorry, go ahead.
they put together over the years images and film sequences, some of which are computer generated, some of which are the result of observations, for example, from the Hubble telescope, some of which, who knows? They invented a whole skunk works just to make images for this film. And the narration is just asking in different ways, what are we doing here? What is this for? What's our place here? What's our role here? It's meant to inspire, and to my experience, it does magnificently.
Now, in your job as scientific advisor in the movie, I mean, you're trying to, of course, establish that the veracity of whatever is being communicated through whichever medium is accurate. Now, in some cases, I suspect that there is some artistic liberties that are taken where you can't exactly know whether it happened visually in that form. How do you sort of, how do you navigate through this delicate balance between sort of the artistic freedom that has to be infused since we can't exactly replicate all that we didn't see, and sticking to the veracity of the information? Is there a balance to be struck there?
In my domain, so I'm a physicist and a cosmologist. I was I was mostly concerned with those sequences, and they are correct. The early sequences in the film coming from the evolution of the early universe, the large-scale structures, the formation of galaxies, are taken from either observations or computer simulations of those early days done by scientists. So it does represent our best knowledge of what happened in the early days. And my impression is that it goes through star formation and planet formation, things where other people are experts. It does represent our best knowledge. But there's a deeper thing that the film does. To my mind, the most important thing we've learned about the universe is that it is a story. It has a story. It's never static. It's never the same. And its story is a story born of simplicity, of utter symmetry and simplicity, out of which continually grows and elaborates complexity and structure and beauty. And the film tells that story in images, in music, in a little bit of narration. And that was the most, apart from the details and the facts and so forth, the most important thing that he got right is the spirit of what we've discovered about the universe as an evolving historical entity.
Very nice. I look forward to checking it out. I maybe even I have young children, so hopefully this will ignite a love of science in them. Um,
I'm also going to take my 10-year-old.
oh, very nice. There you go. Too bad that we don't live in the same city. We'd all go together as one big happy family.
You're
uh,
welcome to come here,
well, thank you. You're in Ontario, correct?
Toronto.
Toronto. Okay. Um, so I guess the next thing I want to talk about is, are you familiar with Richard Dawkins' middle world idea? Do you know what that
I'm
is?
very familiar with Richard, but remind me what is middle world
So
idea?
middle world is, if I remember the term correctly, is this idea that our brains have evolved to understand things at a scale that is relevant to our species, and so things that happen at the nano level, I guess string theory would be at that level, or the most microscopic level, to the highest of cosmological levels, are things that our brains haven't evolved to understand phenomena at those levels, and hence we exist in middle world. So do you think that one of the reasons, I mean, other than the mathematical obstacles to entry, do you think that the fact that most people are stuck in middle world is what makes physics so intimidating to most people?
No, I think it's intimidating because it's not well taught.
Okay. How
Uh,
so?
the history and the beauty of its physics and science in general, but physics especially, is a history of ideas, bold ideas, hypotheses, experimental discoveries, theoretical insights. And what's taught to most in most schools up through university are recipes of manipulating equations, plugging into numbers to equations, getting numbers out. And this is just a tool that we use to check whether our ideas are correct, but it's not the essential core of the subject. The question of how it is that we can comprehend phenomena that are not human sized, they're too small or too large, is a fascinating question. I think that somehow evolution has given us the capability for abstract reasoning, for visualization, for generalization, for hypothesis. All these things must have been useful back in the days when we were hunter-gatherers trying to figure out what we were doing. And to me, I imagine that ever since we were human beings, we've been sitting around the campfire and wondering, what are we doing here? What's all that going on in the sky? What are all the animals? What's our relationship to it? What is life? What is death? What is their meaning? And we're the same creatures as 80,000 years ago or 100,000 years ago. I think the tools that evolution gave us that let us thrive as hunter-gatherers back on the savannah are adequate to forming hypotheses and doing experiments and observations to test them on the cosmological scale and on the elementary particle scale. They're just tools of hypothesis and testing ideas and reasoning.
So if I were to summarize what you said, it's not that. So in a sense, we have a folk physics in us that allows us to properly tackle these phenomena. But then what might make them impenetrable is that the tools become too intimidating. For example, can you be a working physicist without being a very proficient mathematician?
No, at least reasonably competent as a mathematician. Because here's the thing, here's what I understand about science and how science works. We human beings are storytellers. We love to make up stories. And we fool ourselves constantly, relentlessly. We're always making judgments from insufficient information. That's what we're good at. There's a tiger over there, move. Oh, it wasn't a tiger. Okay, go back. I mean, we're always forming judgments quickly from insufficient information, and consequently, our brains are overcharged and we fool ourselves. Science is a collection of methods, social practices, and ethics, which are all designed to diminish our capacity to fool ourselves. They're mostly tools to check errors because we make mistakes all the time. Scientists aren't the people who in math class didn't make any mistakes. They're the people who understood how to check their mistakes and find their mistakes and move on resiliently. So math is a necessary tool to formulate precisely our ideas and our hypotheses, to test them and to reason with them. And if you don't have facility with that tool, it's like trying to be a composer of classical music without being able to master an instrument. You
Nice.
might try it, but nobody in the history has so far succeeded. I get mail and email all the time on almost a daily basis from people who think they can get around this. And I'm sympathetic. I love rebels. I love outside influences. But in all the years I've been doing this, I've never seen one proposal that was worth anything that didn't come from somebody with at least a competence in mathematics and the tools that we use in science.
I loved when you started this, your response to this segment, you said storytelling. And one of the tools or pedagogic tools that I use when I'm training my graduate students as in terms of how to be good writers is, they'll give me something and I say, I can't tell what the story is here. You have to excite me in the same way that a fictional, account has a certain cadence to how you start the story, it unfolds, there's a climax. What's the story here? What's the roadmap? How do I know where I am in this? So it's interesting because I use the exact same terms in trying to impart to them that scientific writing doesn't have to be boring. I mean, yes, of course, there's a particular structure that is implicit to academic articles. I mean, there's the introduction, the research question, the hypotheses, and so on. But within each of those sections, you can still be an exciting, engaging writer, correct?
I agree absolutely, and probably you'll agree it's the same thing when we train our students to give presentations, because it's necessary these days to be a successful scientist to be persuasive in seminars, colloquia, whatever opportunities you have to present your work verbally. And I'm constantly telling to them, this is not an exam, this is not a homework problem, this is a chance to tell your story. And you have to put in a few details, but the arc of the story is what's persuasive.
Very nice. So next I wanted to get into, and now I have to take a big gulp because I'm going to see if I can actually understand anything that you're going to say next, because I consider myself to be part of the greater group of lay people when it comes to physics. But the only thing that I might have that's beyond the layperson is that I am an evolutionist. I first became aware of your work when I was trying to generate. So in one of my books, in my 2007 book, The Evolutionary Basis of Consumption, in chapter 2, I've got this big table where I list, you know, a wide variety of diverse fields that have been infused with evolutionary thinking. And I specifically tried to generate as many fields as I could to demonstrate the ubiquity and the applicability of evolutionary theory. And then in a 2011 special issue that I had edited in a journal called Futures, I did a similar exercise. And in that particular paper, I came across your cosmological natural selection. And before you explain to us what it is, let me just mention for the viewers who are watching, I guess at the lowest possible level within an organism, we've got Gerald Edelman's neural Darwinism, where he actually uses selectionist arguments to explain how the brain makes certain decisions. And in your case, you're taking the mechanisms of natural selection to the highest possible level, cosmological natural selection. So perhaps in the simplest possible terms, you could explain to us what that idea is all about.
Well, let me start, since we've been talking about stories, by telling you the question or the problem that it was designed to answer. In 1986, let me back up. In 1984, there was a lot of excitement about this theory called string theory, which was supposed to be a unique theory which unified the elementary particles and the forces, and hence would predict many features of the elementary particles that we don't understand. We have a very good theory of the elementary particles and forces called the Standard Model, but it has free adjustable numbers in it. It's like dials on a piece of electronics. You can tune it. You can tune, say, if you're making a recording, you can work with 16 channels and tune the bass, the treble, etc., independently. Similarly, there are about 30 dials on the Standard Model of particle physics that have to be finely set and tuned.
What are these dials? They're natural constants, like Planck's constant?
Actually, they're not those numbers, and I won't go into why,
Okay.
but they're the masses of the elementary particles,
Okay.
the strengths of the different forces, things like that. And you only get a universe with all the complexity and beauty and the hospitality to life with very precise settings of many of these dials. So how does that come to be? And the unification of the physics was supposed to answer that. So we had high hopes that string theory would answer that. Now, in about 1986, we discovered that string theory actually came in hundreds of thousands of different versions. And those versions correspond to different tunings of the dials and other dials yet not even contemplated yet. By 1987, 1988, further research had proliferated the number of string theories to a vast, basically uncountable set of string theories. And a friend of mine was involved in this work, Andy Strominger, who's a very prominent string theorist since then. said to me it wouldn't even do any good to find the version of string theory that agrees with the levels of the standard model, with the settings of the standard model, because there's so many string theories, there's bound to be millions of them that agree, and of course a vast number that don't agree with experiment.
So would that
So
fall under sort of Popper's, it's non-falsifiable because whatever you come up with, there would be some version that would be validated by.
yes,
Okay.
yes. There would be many versions that would be validated, so you couldn't get any advice on looking ahead on what the next set of experiments should discover. So I thought about that, and I took that crisis to heart and spent a lot of time just wondering about it. It was a great disappointment. And at the same time, I was reading books for recreation by the great evolutionary biologists, by Richard Dawkins, who you mentioned, Lynn Margulis, Stephen Jay Gould, and so forth. And somehow the idea came to me one day when I was sailing to try to see if I could use the strategy that evolutionary biologists use to explain the complexity and the structure of living organisms to this problem of the tunings of the parameters of the standard model. So, because the outcome in both cases is the same, is a very complex system. And so I read into theoretical evolution, evolutionary theory, and mathematical population biology, and very consciously set out what I needed. I needed a means for the universe to reproduce itself. I wanted to analogize these settings of the parameters of the standard model to the genes. So I needed a space of those parameters like there's the space of the genes, and there was a concept available from the evolutionary biologists called the landscape of the genes. So I adopted it for the landscapes of the models of physics. And then I needed some reason for there to be selective advantage. And thinking about it, I made use of an old idea that two of my mentors had come up with in the 1960s and explained to me, the idea that black holes are actually sites of reproduction of the universe. So rather than time ending in the core of a black hole, or what we call a singularity, time would continue through the birth of a new region of space and time. That was an idea that Johnny Wheeler, who was one of the great American physicists of the 20th century, had invented and popularized. And then he had also played with the idea that the parameters of the laws of physics would change when that happened. He called it reproducing the universe or reprogramming the universe. And all I had to add was that those changes be small so that there could be progressive fitness to have a scenario which was analogous to natural selection. So the fitness had to do with how many black holes the universe would create as a function of these parameters. If there are choices of parameters that lead to a universe that has many progeny, that's going to fill up the population of universes. Whereas if there's other choices that have no progeny or few progeny, they're going to be very rare in the population of universes. So as a way for universes that are fit in that they have many daughter universes to proliferate and to become dominant in the population of universes. So that's the scenario. And remarkably, although the problem, as you noted right away, is testability, this idea
I was just
is
going to ask that.
testable.
Exactly. Yeah, go ahead.
So it leads to some predictions. It would take a little while to explain why I get to these predictions. But one prediction is that the heaviest neutron star, a neutron star is a certain end state of the lifetime of certain very massive stars. There will be no neutron stars heavier than about twice the mass of the sun. And this is testable because there are a few dozens of neutron stars which have been discovered in a way that their masses can be measured. And the masses turn out to be about 1 and 1.4 times the mass of the sun, 1.5 times the mass of the sun. A few are heavier, but none are heavier than twice the mass of the sun. So far this prediction, which I made in 1992, still holds up.
So how many different predictions would stem from this idea, which would have to be tested before we pass if you like, a threshold of cumulative evidence that then allows us to say, well, I think we've reached enough cumulative evidence to suggest that Lee Smolin's cosmological natural selection? Because I mean, I find what you're
More than I have.
more than
Uh,
you have. Okay, but of what order of magnitude? I mean, is it there are four other phenomena that, if tested and validated, you're on your way to Stockholm, or not? Or I mean,
I
what?
don't think I'm on my way to Stockholm with this idea. I think the idea is so radical. First
Well,
of
maybe
all,
that's why you'd go to Stockholm. As we both know, some of the ideas that led to Nobel Prizes are reflected by the fact that those papers were originally the most rejected. That's actually been shown bibliometrically. So that it's radical doesn't mean that it's not good, right?
listen, it's that season, and I'm not losing a moment of sleep.
So
I
how?
have friends who are staying up, who have better reason, much better reason, who are staying up late at night, sleepless, waiting for that phone to ring. It ain't me. My sense is that this idea may be true. It's most likely false because any single idea is most likely false, but it demonstrates something which to me is a very important lesson, which is that by considering the idea that the theories of physics, the laws of physics, evolve and change in time, you make science more testable and more falsifiable. So that I do believe that whatever the fate of this idea, the future of physics is going to be necessarily embracing the idea that the laws evolve and have a history and have a dynamics.
It's interesting that in explaining how you would go about testing your idea, it speaks to how the historical natural sciences, how their epistemology is built, right? Where oftentimes you can't necessarily conduct an experiment in a laboratory, where you instead have to sort of look at some distal past and try to find ways to test something. Now, I know about this because, as somebody who has spent the last 2 decades trying to infuse evolutionary theory within the behavioral sciences in general and consumer behavior in particular, I've often heard, oh, but this is just so storytelling. You're not doing a 2 by 2 design experiment in a laboratory, because that's epistemologically, many of my colleagues, at least in the social sciences, are very much fixated on that epistemology of science. And one of the rebuttals that I offer them is, if that's all that science were, then we better tell geologists and astrophysicists that they're not real scientists, because they're obviously not adhering to your 2 by 2 design in the laboratory. So I'm delighted to be hearing from a theoretical physicist explain about the epistemology of something other than manipulating something in the lab.
Well, the universe as a whole can't be fit into any single laboratory. One of the things I've learned by thinking about this theory is that we have to treat the universe as a whole as a different kind of object from the point of view of science. My last book that you mentioned, The Singular Universe and the Reality of Time, was co-written by a very interesting philosopher, Roberto Mangueira Unger, who's a professor of law at Harvard and a Brazilian politician, and really the intellectually most ambitious person I've ever met. And what we developed working together over some years, which led to this book finally, is really an understanding that the idea that the universe is ultimately static, ultimately reflects some platonic, eternal, outside laws. Outside that is, they influence what goes on in the universe, but they can't be influenced. This idea has come to the end of its usefulness. And when we are confronting cosmological questions, why was the initial conditions of the universe just right to create a universe of such structure and organization and beauty? Why were the laws chosen, and why are they just right to do the same? What happened before the Big Bang? What's going to be the long-term future of the universe? We have to rethink our methodologies to be more scientific. In other words, when we get to the scale of the universe as a whole, there's a danger if we keep using methods which apply to laboratory systems of science blending into myth making, and as you say, just so stories.
Right.
To prevent that, to keep science scientific, I mean, this is something, of course, that the philosophers of science like Paul Feyerabend were saying a long time ago. There isn't one method of science. We have to continually adjust and develop our methods to bring forth the best explanations for the problem at hand.
Well, I talk about, in some of my theoretical writings, I talk about methodological pluralism and epistemological pluralism.
Yes,
And I'm sorry, go.
without having read you, I agree with those phrases.
Well, thank you. It's an honor to be hearing them validated by someone like you. I mean, the idea, of course, is, I mean, the reason why I make those points is that I'm trying to actually sell the epistemology of evolutionary theory, because I'm arguing that evolutionary theory promotes exactly these two forms of pluralism, because the very nature of how you try to solve problems within evolutionary theory, you can't be methodologically fixated. You can't be epistemologically fixated. If anything, you do exactly the opposite. You build what are called cumulative network, nomological networks of cumulative evidence to be able to then construct an adaptive story. And here I don't say story in the pejorative sense of just so storytelling. I mean a scientific story. And so that selling point has been very difficult. I think I'm getting a bit better at making it so that more and more social scientists are coming my way. But it's been a very difficult point to get across to many of my social science colleagues, not so much my natural science colleagues. And I think it's precisely because they're quite myopic, both in their methodological commitments and their epistemological commitments.
Yes, I don't know those fields, but what you're saying makes a lot of sense to me.
Oh, well, there you go. Let's move on, I guess, since we're talking about natural versus social sciences, hierarchy of the sciences. And here we can mean it in several ways. We can sort of go back to Auguste Comte, hierarchy of sciences, and sociology comes on top because it's the most complicated systems that we're trying to understand, and therefore sociology is most difficult to understand because it has the least predictability, whereas physics, by the sheer nature of there being sort of these natural laws, make it, quote, easier to understand. So that's kind of like several hundred years ago. Now, when we talk about hierarchies of sciences in a colloquial way, we typically mean that, physics and biology and chemistry are somehow more prestigious, more influential, more serious than, other sciences and certainly social sciences. Now, my contribution to that discussion, which I cover in some of my writings, is that what makes physics, chemistry, and biology, quote, more prestigious and so on, is because they operate using a consilient tree of knowledge, right? They are these organizing trees, epistemological trees, where everybody could agree on some core knowledge before we sort of move on up or down the tree. Whereas in the social sciences, we could disagree at point A, right? You have sociologists who believe that there are innate sex differences, and you have sociologists who don't believe that there are innate sex differences, and everything is due to a social construction. There are social scientists who don't believe that biology matters when it comes to human behavior. So when the bifurcation happens at that level, then how can you build a coherent and consilient, domain of knowledge? And in my view, this is why physics and chemistry and biology are able to have so much more success at developing these wonderful fields of science. It's not because, every physicist is smarter than every sociologist. It's because he or she is operating within these organized domains. What's your view on my explanation?
This could be an element of truth in it, but I'm afraid I'm a little more pragmatic. I think physics has the prestige it has because we made a bomb 70 years ago.
So really, it's as practical as that?
Well, I was, I'm American originally. I'm very proud to be Canadian as well now.
Okay.
But I was educated in the United States just really two intellectual generations from the people who made the bomb, and just one from people who had a lot of money and prestige by consulting for the Defense Department on applications of nuclear weapons and so forth. And, it used to be possible, it's no longer possible, it used to be possible to go to the governments, whether in the United States or Europe or the Soviet Union when it was the Soviet Union, and say they're spending such and such a billions of dollars to build a particle accelerator to deepen our knowledge about the elementary particles. And we have to do the same because there's a chance that this could lead to the discovery of a new form of energy, which could result in a new kind of weapon. And we can't let the West or the East or whoever get ahead in the possible discovery of something which is weaponizable. And I think that physics has largely lost that prestige, for better and for worse. I think that it's been a difficult period for physics. We finally have some good experiments which advance our fundamental knowledge, and much of the speculation of the last 30 or 40 years has not been borne out by experiment. So it's a moment of crisis for physics, and I think that can hurt. Biology similarly has prestige, and by the way, there's a little subtext here that we could have a discussion about. But one of the painful things that I discovered in my career is how much scientists, friends of mine, and I have to confess, me myself, care about status and prestige. This image of us as deeply idealistic, yearners after universal knowledge is true.
Just because you're a scientist doesn't mean that the evolutionary imperative cease to matter, right? So
Right,
status seeking is an evolutionary drive, and just because you studied physics, biology doesn't go out the window. But go ahead.
right. Well, it took, I had to learn that because I came in, having read romantic things by Einstein and Schrodinger and the other 20th century greats. And so, but anyway, but the connection of biology to medicine and the hope that through advances in biology there will be great breakthroughs in medicine underlies, I think, and I think this is a good thing. I think that as I get older and I see what disease does to family and friends of mine, I think that the career of a scientist not working on medical issues like cancer is wasted almost. I mean, I don't feel that all the time, but it is a period when there are great revolutionary developments possible in our understanding of biology, neurology, the brain, and so forth. And physics, in the meanwhile, in the period of my career, has had a very frustrating period. So now, when it comes to the social sciences, I'm not very much of an expert. I do have a few friends who do, political science, political theory, and so forth. I have a sense that what you described as the lack of a consilience framework is really reflects their being in a kind of pre-revolutionary situation. They're before the great unifying revolutions that in physics were Newtonian mechanics and then quantum mechanics and relativity. Then biology undoubtedly was Darwin and genetics and the great synthesis of Mendelian genetics and Darwin, as you know. And the social sciences have this kind of great unification ahead of them, which makes it a very exciting period to work in those areas, I'm sure.
Well, incidentally,
Hey,
if I can interject, excuse me for interrupting. What the unifying framework that you speak of is exactly that which I've been pitching for 20 years, and it's basically evolutionary psychology, right? You can't study, disciplines or subdisciplines within psychology, such as perception, our perceptual system, or motivational theory, or our memory system, or our emotional system. These things are studied independently of one another as if they magically appear, right? They're just emergent properties. Whereas, of course, what unifies, I mean, the thing that permeates across all of these things, the things that unifies them, is evolutionary theory. So what you are hoping for is precisely what I and others have been trying to do, which is argue that what would be the unifying framework for the behavioral sciences, if not the social sciences in general, is evolutionary theory.
that makes sense to me. If I can mention, I've just read a book by Tom Wolfe, Attacking Darwin and Chomsky.
Oh,
And
I heard about it, but I haven't read it. Go ahead.
it's a wild book, and Tom Wolfe is a great writer. but it suffers from basically his agenda is that in his mind there still is a line between the animals and human beings, such that we can be understood without evolution. So he would be strongly opposed to you, and he would say that language, which is what for him, of course, as a writer, language is the thing that identically makes us human. And he attacks Darwin and attacks Chomsky on the idea that language can be understood ultimately from within an evolutionary framework. And he is grasping on to the hope that there remains this absolute line between human beings and the rest of biology. And it's rather disturbing and rather sad when you see, I mean, he's a great stylist and clearly a very smart guy, but everything is in the service of holding back the understanding of human beings as a result of evolution.
That, by the way, that bias has been coined, not by me. I can't remember the exact reference, but it's called the human reticence effect, which basically speaks to exactly what you said, which is that, people are perfectly happy to use some evolutionary principle X to explain, the mating behavior of the zebra or the salamander. But if you use that exact same principle to explain the behavior of humans or human mating systems, then it's no-no. Or, for example, people are perfectly happy to explain or to use evolution to explain the evolution of our morphological traits. Why we have opposable thumbs, why our kidneys are formed the way that they are formed. But if you talk about anything above the neck, it's a no-no, because that's where our personhood lies. So that bias is so pervasive that it now has been coined as the human reticence effect. And I think that's one of the key obstacles in the social sciences in terms of why people don't like to biologize those disciplines, because they typically argue that, precisely as you said about this gentleman, that what makes us human is that we transcend our biology, right? That's the difference. That's the line in the sand. So don't use the mechanism for the mosquito and the dog and the zebra to explain my behavior. That's vulgar. That's grotesque.
And he closes this wild book, it's a wild book, with an image of him sitting at home in his apartment in Manhattan, contemplating a book of photographs of chimpanzees bedding down for the night in the trees, versus what he can see from his window, which is one of the great hotels of Manhattan, the high class, expensive hotels, and what's available to bed down for, $1,000 or several $1,000s a night across the way in this great hotel. All of it being an unbridgeable gap between how the chimpanzees sleep and how we sleep, all because of the ability to use language. And it never seems to occur to him that however much of a difference there is, and however important language is, which of course it is for who we are and what we are, the facility, the ability to learn and to use language must have a basis in evolution. There must have been a story of how language evolved. We don't know it yet, as far as I can gather. There's a lot about language that remains mysterious, but that doesn't mean that it's inexplicable. It just means that there's good science to be done.
Fair enough. Next question. I mean, following the same line, I'm not sure how comfortable you are to comment about this, but I hope you are. What do you think of the intrusion of some of these frameworks that most people would consider to be anti-science, postmodernism and so on, where they try to make incursions into the natural sciences? So you may have heard, for example, of a call for a feminist physics. There is now a paper on feminist glaciology. I'm not kidding. There is feminist mathematics. Now, of course, if there ever were fields that are independent of the identity of the observer, it would be certainly mathematics. I mean, right? As far as I know, number theory does not change depending on whether the person studying them ovulates or not. So what do you think it is? Is this just a little bleep of lunacy that has infected the academe for a while and it's going to go out? Or is there any value to this framework? And here I'd like to sort of bring up, in case you're familiar with it, do you know who Alan Sokal is? Do you know the Sokal?
We're friends.
Oh,
we're good friends.
There you go. So you know about all this. Do you care to comment at all about this stuff?
Let me take your question and divide it into two questions.
Sure.
First, the issue of feminist science, and then postmodernism and the postmodern attack on science. So, an early person to write about feminism with respect to philosophy and methodology of science is Evelyn Fox Keller, who has been an influence on me and somebody I've admired for many years. So I'm just going to bracket this and put it to one side and say I haven't read most of that literature. Like every literature, there'll be silly stuff in that. But attacking the methodology or the sociology of science from a feminist perspective, I can see worth to and value to. And we can come back to that if you want. And I don't think the people in that area that I respect are not saying silly things like mathematical truth depends on gender or anything like that. They may be saying something like the sociological organization of these subjects is heavily dominated by men, and this has certain ramifications that need to be explained. But so I'm just bracketing that because I think that's a separate issue. I love to quote my friend St. Clair Cement, so let me quote him again. Back in the day, I was trying to understand what postmodernism was. And I was going to bookstores and reading books by Jacques Derrida and so forth.
Uh-oh. Uh-oh. By the
Yes,
way, reading Jacques Derrida or Jacques Lacan or Michel Foucault is substantially more obtuse than understanding quantum mechanics.
yes, but I found it's very difficult to understand what they all were up to. But I found it possible to comprehend what postmodernism and art was supposed to be. And this is again quoting St. Clair Cement. He said, if the purpose of modernism in art was to burn the whole house down of classicism, then all that postmodernism has been doing is playing with the little charred bits which are left over, which is a pretty puerile thing to be doing considering that winter is coming. So is the leader of a generation of artists working in New York who see themselves as transcending postmodernism, and postmodernism is a thing of 20, 30 years ago. Now, the radical, here's how I understood what we call the science wars back in the days of Alan Sokal and his piece. There are intellectual professions where we work with our hands, where we confront nature. And these are sciences, engineering, architecture, arts, where you make something with your hands. And we're working with our hands. We're forever confronting, as I'm sure you do in your work, how difficult it is to make anything of lasting value. Nature pushes back. If you're constantly on the border with nature, trying to make something with your hands work, nature punishes us. It pushes back. It's difficult. And you feel the recalcitrance of nature to our fantasies all the time. Then there are disciplines where people work with text, and they just use the tips of their fingers to type on a keyboard or to write something. And roughly speaking, they don't feel anything pushing back. They just make texts which are interpretations of other texts, which are interpretations of still other texts. And I see a distinction between these two basic modes of facing the world. For people for whom all of their life is about the manufacture and revision and criticism of texts by other texts, it made sense to them to say that, well, nature is just another text and science is just another mode of criticism of another text. And it's just not true. It's not a useful point of view because nature is not a text.
That is the most eloquent and charitable criticism of postmodernism I've ever heard. And I say charitable because one of the ways that I would summarize what you just said is that it's a bunch of gibberish. But you probably wouldn't concede to that point. The reason why I'm saying this is because ultimately, irrespective of what you do, if you're an intellectual, you're trying to understand something. So to use your analogy of using your hands, it doesn't matter what is the endeavor that we're using. We are trying to get from point A to B, where B is some position in the Markov chain where we are closer to some truth, whatever that means. You never read a postmodernist text and go from point A to B. It's more like string theory, or I can't remember the analogy that I would need. Heisenberg's uncertainty principle. It's random nonsense gibberish, right? As a matter of fact, one of the things that I do in my on the SAAD Truth in my show is I take abstracts of laudable postmodernist thinking, and I read them as that basically my whole clip is just me reading an abstract. And unless I am singularly dumb that I simply can't understand the profundity of postmodernism, I've never been able to read one of those abstracts and understand. I mean, I probably would have a greater chance reading an abstract in physics letters than I would in there. So that's why it's anti-reason and anti-science, because it doesn't get us anywhere.
You can tell me you don't want me to do this, but it'll take me 3 minutes. I have a story about when I met Jacques Derrida.
Oh, go for it. Come on. Of course I want you to tell me this.
So I have a good friend who's a feminist legal theorist and a playwright, Drusilla Cornell in New York.
Cornell's my alma mater, by the way.
No, her name is Drusilla Cornell.
Cornell. I'm sorry. Okay.
And she's very well known in those areas, and she's a dear friend. We used to meet once a week in New York in a certain restaurant, and she would try to explain to me these texts, going back to Heidegger and Husserl and so forth. And I never could get it. I didn't have background. So one week, Jacques Derrida came to town, actually at her invitation, to give a series of lectures at different places in New York. And she said, "You have to come and hear Jacques, and he's so lucid, you'll understand." I said, "Well, listen, give me the text that he's going to speak from so I can prepare. And I'll read the text the day before, and then I'll come and see if I can make sense of it." Because this was a challenge, and I'm a theorist. I wanted to respect my friends here and try to see if they were doing something interesting or important. So she gave me the text, and I went home and I read it, and I could not make any sense of it. Then I went with the text to the lecture hall, and I sat there with the text on my lap, listening to him. And you know what I realized? What I realized is that it was funny. It was just a series of jokes.
Okay.
And my French is not very good, but it was puns between English and French and a few other languages thrown in. It was just funny. And when I heard it live with the cadence, it was just entertainment. It was highly intellectual entertainment of a certain kind. So then the theme was his relationship with Lacan, and how he and Lacan lived within a kilometer of each other in Paris, but they never met, even though he dedicated some of his books to Lacan, and Lacan dedicated books and essays back to him. He had so much respect for Lacan, but they never made it to actually have a conversation together. So then there was a party for him afterwards, and I went to the party, and I found myself next to him, and he was very charming. And I said to him, "I don't understand. How is it that in all those years, in all these years, Lacan had just died, that was the occasion for the homage to Lacan. In all these years, you or Lacan never picked up the phone or wrote a note and invited the other to come have a cup of coffee or a drink or something. You lived just a short walk away from each other in Paris." And he said, "If you think that I, as an Algerian Jew, could phone up the great Professor Lacan, you understand nothing about Paris."
Fantastic story. Wow. I'm glad you mentioned it. It now will go down in the annals of scientific storytelling. Thank you for sharing that.
So he was I liked him. I still don't understand or applaud his intellectual project. But I went away thinking he was a substantial human being who had a project to do something. I wish I could understand what. But maybe I'm too charitable.
Maybe offline, although I've already shared my honest opinion of that stuff in public settings. Offline, I'll share with you what I think of those trio of French postmodernists, but we'll leave it for another time. Perhaps we could end. I mean, I know at the Perimeter Institute, one of the mandates that you guys have is sort of public outreach of science, which I guess speaks going back to Voyage of Time. I mean, right, igniting interest in the general public about science and so on. So first, I guess my question to you is, why do you think there isn't a greater number of academics who are using all of the tools that are afforded to us today to precisely engage in this call to action, to do the public outreach, to do the science outreach? I mean, the show that I have that I'm now having you on is really meant to exactly do that, which is I've got this tool that allows me to speak to fascinating people and then share it with a broad audience. Sign me up. I'm so excited to do it. I would have never met Lee Smolin if I didn't have these tools available to me. So what do you think drives the reticence of most scientists from doing this?
First of all, let me give a name to what we're doing here, because what we're doing here is having a conversation from different frontiers of scientific knowledge with each other that the public can look on over our shoulders. That is, we're having a good time, we're having an interesting conversation. We can talk pretty seriously at the levels that we are natural to us, and the public can learn a lot by looking over our shoulders at this conversation. So this is not journalism, this is something more interesting. This is conversations between people at different frontiers. And I would add to this conversations with artists. And I would say that the Terry Malick experience of the film is part of a conversation of Terry Malick as a great artist, playing back what he's learned from scientists. So there's a name to this community of people on the different frontiers conversing with each other that John Brockman gave, which is the third culture. It's the answer to C.P. Snow's two cultures.
Exactly.
And it's different than just public outreach. It's a necessary conversation to help make our culture more coherent by having we at the frontiers understand what each other is doing and thinking. Now, this is part of what we do at Perimeter. We also do more traditional education, pedagogical material, and so forth. And let me say, I think this is very important to do, first because we live in a democracy, and so many of the key issues that our democracies have to address are scientific in nature, to start with climate change, but many medical issues, many environmental issues, many issues of energy, et cetera, et cetera, et cetera. And we need for a democracy to work, we need a public which knows how to evaluate claims about science and knows how to educate discussions about science. So this is a necessary thing. Now, we found at Perimeter there is enormous interest. We have public lectures once a month. We used to hold them in the biggest auditorium available in Waterloo, Kitchener, which was a certain high school auditorium. We got upwards of 700 people coming, and we could have filled an auditorium which was twice that. There's enormous interest. There's also, we're very grateful and proud that we are well supported by the governments of Canada and Ontario. And those governments, we find, care a lot that we do this outreach. It's not a small thing for them. They know that we're doing a good service. And it seems to me, just speaking about Canada for a moment, that the service that we perform at Perimeter in our area, scientists all over Canada could be doing much more aggressively, much more confidently. And there's interest, I'm sure that there's interest both from supporters like the government and private foundations and from the public itself. So I don't understand why more people are not doing it. It's an intrinsic part of our responsibility as scientists to take our case to the public as well as to other scientists.
My feeling is, I mean, to answer my own question that I posed to you, is that I think that it requires a particular set of abilities that many academics don't necessarily feel that they possess them. And so, you could be a master of your, knowledge base. You could be a great practicing scientist who knows how to work within the confines of your very narrow areas of expertise and be a brilliant scientist. Yet that doesn't mean that you could take this out on the road to a broad show and speak in a way that ignites the passions and the interest of the greater public at large. You don't necessarily have the extroverted personality that allows you to engage people who are not, with you in the ivory tower. So my feeling, I think, and you'll correct me if I'm wrong, or you'll add or to it as you see fit, is that they'd like to, but they don't necessarily feel that they have the ability to succeed. Does that sound like that's probably the number one obstacle for more people getting into this?
That, but I'll be my cynical side.
Okay.
Then I'll come back with my hopeful side. As you mentioned, there's a hierarchy among sciences and there's an elite. And the elite among older generations of scientists are comfortable with the kind of insider control that they have working within the hierarchy and within the elite. And what I see happening is people like you and me reaching out to the public, but then also the younger generations of scientists, the people who are postdocs and young faculty now, are using new tools like blogging, like podcasts, to break down the hierarchy and take their arguments and their interpretation and their views about the progress of science to a wider audience, which again, the blogs in any area are written both to other colleagues and to the public. And a number of young people in my field have turned out to be incredibly influential, because they influence how all of us in the profession think and talk about what we do. Just sitting there at the keyboard and every week or two putting out a blog, taking on some issue that's of importance in the science.
Well,
and so I see that as democratizing and hopeful.
And to bring it back to a Darwinian perspective and to use Richard Dawkins' term, right, the meme. I mean, we're ultimately in the business of creating memes or memeplexes, if we call a collection of memes a memeplex, in this case scientific knowledge, but then disseminating those memes, right? I mean, a virus is successful if it spreads, right? Genes are successful if they replicate and spread. Well, you and I and any academic, any thinker are in the business of creating and then propagating memes. And so to the extent that we have these tools, so nobody is suggesting that we shouldn't still be doing, the science that gets published in the academic journals. But then there's the next step. It's kind of like if we try to analogize with natural versus sexual selection, right? I mean, it's one thing to survive as an organism, but it does you nothing to survive if you don't then reproduce, right? It's a two-step, life is a two-step process, right? I've got to survive and then I've got to reproduce. So it's one thing to produce the knowledge, but then I've got to spread that knowledge, right? And to the extent that the blogging and the podcasting and the conversation with Lee Smolin allows me to spread interesting memes, then that has to be part of the definition of what my job description is. And I suspect that, as we move forward, I'm willing to bet that if you and I sat down in 5 years, we will see that probably a greater number of CVs, academic CVs, will probably have a section that measures the impact, the mimetic impact of someone's work beyond academic citations. Do you foresee such a future?
I agree. Also, just to come back to what we were saying about storytelling, when I was a graduate student, there were lots of guys around, they were all guys, to come back to that, who could show up for a seminar unprepared, talk at the blackboard, mumble into the blackboard, be incomprehensible, but everybody knew they were brilliant and they had good careers. Their writing was incomprehensible, but 3 or 4 people at the top said they were brilliant, what they were doing was important, and that was enough. The standards have gone up year by year since then. Now the young postdocs with good careers give good talks, they're well prepared, they use good presentation skills, their writing is vivid and fluid. Not everybody, but the standards, the general standards that I see and hear when I read a paper or go to a seminar are much higher. And there's a sense in which more international cooperation, competition, more international input, more democratization are playing a role to improve the level of communication in the sciences.
Very nice. As we wrap up, are there any projects that you're currently involved in beyond, of course, the forthcoming Voyage of Time that you might want to promote now to the public that's not yet publicly available?
Well, so I'm writing one more book in the genre of science for the general public, which is about quantum mechanics and how to make sense of the mysteries of quantum mechanics. So that will come out in about a year, we expect, something like that. Beyond that, I'm a scientist. I go to work every day. I had a great idea about the dark matter last week, and I've been waking up at 3 o'clock in the morning and 5 o'clock in the morning and 6 o'clock in the morning, turning it over in my mind, talking to colleagues about it, trying to work it out on paper, writing drafts of it. It's probably wrong, like every other idea of the dark matter, so forth. But I'm just trying to do my job and discover something true.
Wonderful. It's been an absolute pleasure, Lee. Please stay on the line. This will be up hopefully later tonight, if not tomorrow. A real honor and pleasure to have spoken with you today, Lee.
Likewise.
Thank you.
Thank you very much.
Thank you so much.